So let's join question 9. Question 9b, show that A plus B is irrational if A is rational and B is irrational. That's what we did in part A, except that we had a specified number that was irrational there. But we had A irrational because it was 1, and then B irrational because it was root 2. So sure. So say let A plus B be equal to P over Q, with Q not equal to 0, PQ are integers, and PQ are coprime. So they do not have common factors.
Sir,
Hello.
coprime and cofactor, they is
Coprime and cofactors of, except when you say cofactors, in this course we interpret cofactors again as some numbers of some matrices. Also, I'm not using that term here. But there's no difference there, except that we only use cofactors for matrices. Anyway. So yes. So A plus B is equal to P over Q, with PQ meeting those conditions here. Then we'll have, so we'll leave B now, which is irrational. So B is not irrational. So we'll solve for B. So we'll have B equal to P over Q minus A over 1. But this is the same as Q down, P minus AQ. Then you say, but P minus AQ over Q is rational. And B is irrational. Hence, a contradiction. So we have this contradiction here. So A plus B is irrational. So hope you get the idea behind this thing. You just want to have that number which they have said is irrational in the question. You make it the subject of the formula. Then on the other side of the equal sign, you have an irrational number. So once you make it a subject, then you say, oh, since I have this my subject here, which is irrational, equal to the other part which is rational, then the two are not the same. That's how you simplify. This is the basic thing that you need to have, and you can solve any question of that nature. I can give you a question like, let's call it B1. Given that root 3 is irrational, show that 2 over root 3 plus 1 is irrational. Solution. The target is to solve for root 3 after you have made this statement here where we assume. So say, let 2 over root 3 plus 1 be equal to a over b, where b is non-zero, a, b are integers, and a, b are coprime. This statement here, this one is a must. You always put these assumptions there. Then now you come down and solve for root 3. So we'll have 2 over root 3 is equal to a over b minus 1. Of course, you can say 1 over 1 there. This is the same as 2 over root 3 is equal to b down a minus b. And then you cross multiply. So cross multiply, you have root 3 a minus b is equal to 2b. Then you divide by a minus b, divide by a minus b. So you have root 3 is equal to 2b over a minus b. So once you have that, then you say, but 2b over a minus b is rational, and root 3 is irrational. Hence, the contradiction. So 2 over root 3 plus 1 is irrational. So if there is this condition that given that root 3 is irrational, in our solving after this assumption, our target is to make root 3 the subject of the formula. Once you have managed to make root 3 the subject, then you conclude, because whatever will be on the other side will be rational. And yet root 3 has been given as irrational. That's a general way of taking these numbers. So now we go to 9C. C, find an irrational number. Find an irrational number that lie between 1, 2, and 3. If you want to, some questions are, they look so easy, but then you must be careful how you solve them, because if you're not careful, you fail to solve when the numbers have been tampered with. So in the case of 2 and 3, it's so easy that you can just say, okay, my solution here, since 2, you have 2, you have 3. Since 2 is the same as the root of 4, 3 is the same as the root of 9, then I can just pick any root in between here. That number will be between 2 and 3. For example, you can pick root 5, you can pick root 6, you can pick root 7, you can pick root 8. All these numbers will be irrational in between 2 and 3. But it's not a general way. This is specified. If you have 19 and 19.01, it becomes so tricky for you to know which numbers to pick here. So then what do we do? So you say, okay, then we'll find a general way of doing this. Since we know irrational numbers are mostly prime numbers, the root of prime numbers. So we can go for the smallest prime number, which is 2, and say, we know that root 2, we know that is there a question? Is there a question? Okay, so we know that root 2 is greater than 0. Root 2 is greater than 1. Okay, because the square root of 1. So if there's a question, you can put up your hand, or you unmute and ask. Okay, so because we know that this root 2 here is irrational to start with, it's bigger than 1, so we are sure it's positive. So then, if you take 1 over that root 2, this number here will be less than 1, but it will be positive, bigger than 0. So it's a good argument to start with. So we have this truth here. 0 is less than 1 over root 2, and 1 over root 2 is less than 1. Okay? And then, if I'll be given anywhere, I'll be given an interval, I'll be given 2 numbers, A and B. Clearly, A will be smaller than B. So because A will be smaller than B, if we get B minus A, this number will be greater than 0. For example, 2 and 3. 3 minus 2, we get 1. 1 is bigger than 0. Okay? Negative 4 and negative 2. Negative 2 minus negative 4. We'll get negative 2 plus 4. This is equal to 2, greater than 0. So n two numbers given. If I get the bigger one minus a smaller one, I will have a positive number. So we want a positive number because even if we take it there on that inequality, the positive does not tamper with the inequality. So we'll get back to the inequality and multiply. We have 0, 0 less than 1 over root 2 less than 1. Then we multiply this whole thing by B minus A. 0 times B minus A will give us 0. 1 over root 2 times B minus A will have B minus A over root 2. 1 times B minus A will give us B minus A. For us to retrieve our interval, this interval AB, because we're looking for something in between there. So for us to get back our interval, we'll add, on the left, we'll add A. To avoid changing our inequality, we'll add A also in between, and we'll add A on the right. And we'll add A on the right. So we'll have B minus A plus A. So what have we done? We assumed, we picked this interval here. That is true mathematically. It's like we are saying 0 less than 1 less than 2. This is true in mathematics. 0 is smaller than 1, 1 is smaller than 2. So you can put the inequalities like that. Now we have put up an argument, an inequality that has an irrational number in between. We are trying to come up with an easy way of us getting numbers in between, getting rational numbers in between two rational numbers. So we just went for 0, less than 1 over root 2, less than 1. And then we are saying, because we'll be given an interval, we'll be given two numbers always, for us to find something in between. So suppose I'm given these two numbers. Suppose you're given two numbers, you'll be given A and B. So you're sure that if I subtract the two numbers, my answer will be positive. Because my answer will be positive, and positive does not have validity, then we can multiply now. These are only inequality that we have chosen. We can multiply by B minus A. 0 times B minus A will give us 0. 1 over root 2 times B minus A will have 1 times B minus A, which is B minus A over root 2. Because this B minus A is sitting as B minus A over 1. And the multiplication, you multiply the numerator, denominator, denominator. Then from there, we have 1 multiplied by B minus A with B minus A. Then from here, we want to get back our interval. We want to have A on the left and B on the right. So let's add. We add A, we add A, we add A. So that we get what? 0 plus A, we get A. In between here, root 2 is the common denominator. Then B minus A plus A are root 2. And then B minus A plus A, we get B. What we wanted was to have A and B as our boundaries. And then we are saying this number here is the number we are looking for. This is our solution. This number is irrational. After being irrational, it is bigger than A, but less than B. So this is what you need to know. I'm just driving here to help you understand. But if you don't get to understand this derivation, then you can pick this formula to be using. You can pick the formula to be using. This formula here. You can be using this formula. How do we use it? Let's go to A now. Let's go to part 1. Part 1. Find two numbers in between 2 and 3. So say A is equal to 2, B is equal to 3. And then we'll have numbers 3 minus 2 plus 2 root 2 over root 2. This is giving us 2 root 2 over root 2. So 1 plus 2 root 2 over root 2 lie between 2 and 3. It is irrational and it lies in between there. Second, we have the number 19 and 19. So A is 19, B is 19.01. So we'll say 19.01 minus 19 plus A is 19 multiplied by root 2 over root 2. This number is 0.01 plus 19 root 2 over root 2. Simple. 3, -4, and -2. So this number here lie between 19 and 19.01. Then we have -4 and -2. A is -4, B is -2. Then we are saying in the formula, we have -2, which is B, minus -4 plus A, which is -4 multiplied by √2 over √2. This is equal to -2 plus 4 minus 4 √2 over √2, which is equal to 2 minus 4 √2 over √2. This guy lies between -4 and -2. So all I need to remember is the formula B minus A plus A √2 over √2. What if they say find two numbers? Find two irrational numbers that lie between 2 and 3. Between n numbers. The first one will be this one. The second one, same formula. Just pick a different irrational number, say 3. So that you use √3 there. You have another solution that is irrational in the same interval. If they want another one, you can use √5 there. You can use √7. You can use √6. You can use √11. You can use √13. Any number that you can use, you just change the irrational there. So you don't need, if it's too complicated for you to drive this, then forget about it. Just pick this formula here. You can never fail to give numbers that lie in between two numbers. You can never fail to get irrational numbers that lie there. You always get them. So let's go to question 10. Question 10. Question 10 says, prove or disprove. So prove or disprove by a counterexample. Where possible. That A, the sum of two irrational numbers is irrational. Solution. Where possible, use a counterexample. So we are saying not true. Is it not true? So we are saying true. This one here is true. The sum of two irrational numbers is irrational. True. Maybe we need to say true here. So prove or disprove. So let's just prove. So let √2 and √3 be two irrational numbers. Then √2 plus √3. So then let √2 plus √3 is equal to A over B, where B is non-zero. A, B are integers. A, B are coprime. Then pick one. and make it the subject. So we'll make root 3 the subject. So we'll have root 3 is equal to a over b minus root 2 over 1. And then we'll square, this side. So we'll deal with 3 now is equal to, we're expanding. Remember, if you have a plus b squared, you multiply a plus b times a plus b. So we'll have a squared over b squared minus 2 root 2 a over b plus 2. So you take your time and expand a over b minus root 2 multiplied by a over b minus root 2. So you get a squared over b squared minus 2 root 2 a over b plus 2. Now, the only root that we have in the question is here. So we'll make it the subject now, taking everything else the other side. Or we'll take that same part to the left so that it becomes positive. 2a over b root 2 is equal to a squared over b squared plus 2 minus 3. Then this is the same as 2a over b root 2 is equal to a squared over b squared minus 1. Then we divide by 2a over b. We divide by 2a over b so that we remain with root 2 alone. So we have root 2 is equal to a squared over b squared minus 1 over 2a over b. But this is a fraction. These are two fractions. On top, b squared giving us a squared minus b squared. Then instead of using division, we use multiplication so that we have b over 2a. So you can simplify this as root 2 equal to b multiplied by a squared, or to just break it a bit, this b here can divide. So b here 1, b here will get b. So we'll have a squared minus b squared over 2ab. So now we have the statement that we're able to make another question saying, but root 2 is irrational and a squared minus b squared over 2ab is rational, which is a contradiction. Hence, root 3 plus root 2, root 3 plus root 2 is irrational. So I've used an example, but I've used it in a general way, where we try to assume the sum, because we could not get the sum without the calculator. So we've just assumed that, okay, the sum is going to be a over b. Suppose that sum is rational. Is it true that it will satisfy all the properties? But on the way we see that we have this contradiction, so it fails to hold. Are we recording? Yes, we are recording. So we're saying, since the question allows us to prove using a counter example, we have said root 2 and root 3 as our examples, then we add the two irrational numbers. So we're adding them. Then we say let this sum be equal to a over b with the conditions that satisfies rationality. Then now we take one of these the other side, which we have done. We have root 2 here. Then you square. When you square root 3, you get 3. When you square the other side, we get this expansion here. Then we solve for root 2 because then we have root 2 is equal to this fraction here. If you change this division to multiplication, you have b of 2a sitting like that. So that now this one, when we simplify, you get this. Root 2 is irrational, the other part is rational, which is the contradiction. So this guy is irrational. That's how you do that proof. Yeah? Okay. So we can end here. Coming too much. So we'll end here. We haven't finished question 10. We'll start from there.
So, excuse me, sir.
Yes.
I'm asking for the slide for question 7.
For question 7, I'll send in the group. I'll send out the video.